Hi, this is Margaret from COVID Help covering verifying quadratic formula solutions with non-reducing fractions. This would have been completed sooner had the university I've been attending not been so stymied for a non-traditional for the student body population, student like myself. Anyway, the problem I'm working with, and I'm sorry if you're colorblind and or cannot see this because these are the conditions under which I'm working, but I have negative 4x squared plus 7x plus 2. You can see many videos on the quadratic formula, so it's pretty easy. It's just, you can't really see this, but it's minus b plus or minus b squared minus 4ac over 2a. Now, I thought I saw some other problems in my homework, but unfortunately I was being overloaded with extra homework that apparently through email that was not part of the homework or not for credit, and who knows, but I didn't get to finish working through some of the other problems. I think there were, but this is kind of addresses the issue I ran across, and when I find that other problem I may make another video, but right now this is the problem I'm working with. We see that the solution is that the solution 1 of the solutions equals 2 and 1 minus 1/4. So when we plug these back in, we get x minus 2 and x plus 1/4. When we factor it back throughout, we get x squared plus 1/4 minus 2x, that's x as well, and minus 2/4. This does not actually give us the original negative 4x, so I multiply times minus 4, which here is 4. I get negative x squared minus 1x plus 8x plus 2, which is what we wanted. The original solution, x squared plus 7x plus 2. I don't see this in other videos. I haven't looked for it. I don't see it often in the homework, in the book. So something I was working through. I thought there were other fraction issues. This is a simple problem I came up with. Again, when I find this other problem that I was not able to complete or locate, I might present it. So finally, the solution doesn't really look like, doesn't look x equals, this is only for these fractions, for these factors. But you still, in order to verify it, to come back, if you were to calculate other values of x throughout the problem, without using that original factor a, you're not going to get the right values. So if you're programming this, and you just use these two values, solution 1 and solution 2, you're not going to get the right values. I'm going to call this S1 and S2. S0, is 2, and S1 is negative 1/4. But you still, the final solution would be A, which is times x minus solution 0 times x plus solution 1. Solution 1. So, again, the final, to verify it, plug it back in. If you want to get values for x, you've got to use this a factor to get the right values. So again, it's to verify and plug back in, I'm looking at a times x minus solution 0 times x minus solution 1, or 0, 1. I like to use them, right? So at any rate, I thought I saw some other issues. If I find it, I will readdress it, but I think the major issue here is when you have a non-reducing fraction in the answer, and you have a factor of a that's not 1, you need to consider the fact that it's non-reducing, or that it's got a factor of 4 here. This does not work out to whole numbers, and it does not give you the correct answers. I don't know why. Maybe I missed something. I've looked through it. I've looked through the videos, but again, if you're going to be using this for anything, and you want to verify you've gotten the right answer, because I like to check I solve the problems. I could have made a mistake and make lots of mistakes. I'm like that a 98th percentile, so I make careless errors. I like to verify that what I've done is correct, and to verify your work without a computer, without a calculator, without somebody saying, hey, yeah, that's the right answer. You might want to do this.